Hi everyone. Just a few more words about this diffraction monochromator, which again is a type of wavelength selector. I want to talk a little bit about the characteristics of a diffraction grating, particularly resolution and dispersion. So resolution is the ability of a grating to separate two closely spaced peaks on a spectrum. So it's the ability of a grating to separate two closely spaced peaks on a spectrum. Dispersion is the ability of a grating to separate two wavelengths through an angle. So it's the ability to separate two wavelengths through an angle. And we'll talk in more detail about what each of these means, but for now, let me tell you this. Resolution and dispersion improve when the grating has a lot of grooves and those grooves are close together. So resolution and dispersion improve when there are lots of grooves in your grating that are close together. I'll mention that again, but I just thought I would mention it now. Let's talk a little bit more about resolution. Again, the ability to separate two closely spaced peaks in a spectrum. So here we're looking at two spectra, intensity against wavelength, and I think any old grating could probably resolve or separate two wavelengths that are this far apart, 550 and 700. But what about in this spectrum here? We've got one wavelength at 550, the other one at 550.05. Those are really close together. Can your grating resolve those two wavelengths? That would be hard, wouldn't it? So there's an equation for resolution. I hope you recognize this lowercase n as order, and this capital N, I wouldn't expect you to know, but it is the number of grooves in the grating. Remember, resolution proves when you have a lot of grooves that are close together. Let's talk about dispersion. Dispersion, we said, was the ability of a grating to separate two wavelengths through an angle. And I don't know about you, but these red and orange wavelengths don't look very well separated. In my opinion, if this were our grating, and if this were that incident beam, and maybe I'll draw a perpendicular to that grating just as a reference. If this were the red wavelength, wouldn't dispersion be better if maybe the orange were here? Isn't the angle between the orange and the red much greater here than it is here? So again, there may be an equation in your Harris text for dispersion, but all I want you to remember is that dispersion improves when those grooves are close together. So that's all I have to say about resolution and dispersion. Thanks for listening.